Hello fellow devs and welcome to the second part of the Phoesion Glow basic series. What's Phoesion Glow? Phoesion Glow is a framework for developing scalable cloud microservices using C#. It offers out-of-the-box mediators, gateway, service bus, service host, Kubernetes operators and more. All components have been created using .NET Core and designed to work together seamlessly to provide a uniform and streamlined experience for developing, deploying and managing your cloud services. In the previous video, we learned how to install the DevTools on our machine and create a couple of microservices. In this video, we will learn the basics of setting up Phoesion Glow to a Linux server and deploying our microservices. To learn how to set up your dev machine and create a Hello World microservice that will be used in this video, please watch the part 1 of the series. This video is split into 5 chapters. First, we will create the Phoesion Glow project file to define our services. Next, we will set up a Linux VM server to host our services. We will deploy our services to the server and show some management and monitoring basics. Then we will create a new microservice and deploy it to our server. Set up SSL for our services using Let's Encrypt. And finally, we will go through the basics of Phoesion Glow architecture and design. Okay, let's start. The first step is to create a Phoesion Glow project file. This file is basically a JSON file that will hold information about the microservices we want to deploy, like where are the files and other configurations. Thankfully, there is a quick tool for managing the project file called Phoesion Glow Project Editor that is installed with the Blaze installer. To create a new project, run the project editor. Create on the New Project button and specify the file name we want to save the project. Usually the same place as your .sln file. Next, we need to add our services to the project. We will add the two services, Hello World and Game Room, that we created in the previous video. To add a service, click on the Add button and select the C# project. Now, this we will add a new entry in the services view and we can further configure the service if we need to. For now, the default configurations are fine. Click on the Add button again to add the second service. Click Save to save the project and close the editor. The PG project file is now ready to be used for deploying our services. Now, let's set up Glow on our Linux server VM. Connect to your VM using SSH. And execute the following commands that you can find in the video description and in the documentation site. First, we install the repository key. We add the repository. And then we install the cloud entity packages. We can either install them one by one or all together, since it's the same VM, using this command. You can find the information of how to set up your Linux VM in the documentation site by going to the Getting Started and the Linux Server Setup Guide. Here are all the instructions to set up your VM. Now that all the packages are installed and the entities are running, we need to create an admin user. To do so, you can use the CLI tool called Lighthouse CLI. You can autocomplete with tab. This will connect to our local machine using the root account. We can add a user using the user add command. We'll use password. We will be an administrator. This is important. Otherwise, we will not have the appropriate access right. Add a name and email. And we will leave this blank to accept connection from all IPs. Now the user has been added to the Lighthouse. We can connect to the Lighthouse using the Blaze tool. Here we need to create a new connection, add a profile name, the IP or domain of our server, the username of the user we just created. We will use password authentication. Now we need to download the key from the server. So this is a key that the server downloads. We can verify this using the Lighthouse CLI. Using the print fingerprint command. So this is a public key fingerprint of our Lighthouse, which is correct. So we accept it and save the connection profile. Now to connect to the server, simply click on the connection profile. And now we are connected to the Lighthouse that is running on our new server. Now let's get a domain and point it to our server. I will use DuckDns, or you can edit your machine host file. In DuckDns, we add a domain below demo, and we point it to the IP of our server. So now let's try it. So now we hit our server that has nothing running on it. Now that we have connected to the Lighthouse and created a domain and pointed it to our server, we need to deploy our services. To do that, we need to create a new quantum space. Think of each quantum space as an isolated box in which we can put a number of microservices inside and bind it with a domain. So requests coming from the specific domain, for example, www.mycompany.com, will be routed to the correct set of services. To create a new quantum space, click the Create New button from the dashboard, specify the quantum space name, for example, My Services, add a domain binding. Now we will use the domain we created from DuckDns, just a domain, no HTTPS, and click Next and save. Now our new quantum spaces is created and is binded to the domain that we created from DuckDns. To deploy our services, enter the quantum space, click the Deploy button, select the project file created earlier, only deploy the Linux architecture. Click Next. After our services have finished compiling, in this step we can apply deploy time configurations. We can skip this step for now and click Next. Here we can examine the changes that will be applied and click Deploy to start. Here we can see that we are adding two new microservices to a quantum space. Our services will be uploaded and the rollout of the new version will begin automatically. Here we can see the rollout progress for each entity of our system. In this case, we only have one of each entities. This is the edge node and this will run our services. Here we can see that both services have been deployed. Now let's open a browser and navigate to the URL to test our services. Hello world. Reader slash say hello. So now we can see our service is running on a Linux VM. Another way to see the routes that are exposed from our service is using the hologram viewer. In the rest tab, we can see all the routes that are exposed for the get, HTTP get method, post, put, and the others. Here we can see the greeter that we just hit from our browser, and you can also copy directly the URL, including the domain. From this dashboard, we can also monitor the health and other statistics of our services, like CPU, health, memory, and examine the log messages from the entire system for this quantum space. For example, in this request that we tested earlier, we can see the incoming request, the messages produced by our business logic code, and the response that was returned back to the client. For the next step, we will see how easy it is to create and deploy a new microservice in our application. First, let's create a new project for the new service. For more information about creating new services, you can watch the previous video. We select the Firefly service project. Let's name it Demo High. We will rename the service. And we will create a new module. And an action. So now that we created a new service, we need to add it to our Glow project. Click Save to save changes. Now it's ready to deploy to the quantum space. The project is already selected, so we click Next. So now that the compiling is done, you can already see the new service is ready for configuration here in this step. Here we can see that we are updating the old services and adding a new one. We can also examine the files added and the modified or removed files, and we deploy. So here we can examine the rollout of our services. You can see the new service has been added. And the rollout has been completed. If we go to the services, you can see the new service has been added to the group. And let's try it from the browser. Let's find the URL. So now we saw how easy it is to add a new microservice in our existing Quantum space. Notice how our APIs are available through a plain text HTTP interface, which is not secure. The next step is to protect our API endpoints using SSL. To do so, we need to create a new SSL certificate using Let's Encrypt and assign it to our Quantum space. To create a new certificate, you can go to the admin panel from Blaze, SSL certificates, add new certificate. We will add a name for the certificate. The domain that this certificate will be issued for, in this case DuckDns without the HTTP. And we will use the Let's Encrypt provider. Here we only need to add our email address and click Save. Lighthouse will request a certificate from the Let's Encrypt services for our domain. Let's Encrypt system will verify the ownership of that domain with a series of challenges that Phoesion Glow handles automatically. Here we can read the agreement. If we accept, we continue by clicking yes. Once the certificate is generated, it's stored in the Lighthouse and automatically renewed in the background. Now that our certificate is ready, we must add it to the Quantum space to use it. To do so, we can go back to the main screen, edit the Quantum space, and in the domain bindings, select the SSL certificate we just added. Here we can enable strict transport security that will auto-redirect unencrypted HTTP clients to the HTTPS URL. Click Next and save to apply changes. Now we go back to our browser and refresh our page. We can now see that we have been automatically redirected to the HTTPS URL and the SSL has been installed correctly. Here we can examine the certificate. That has been issued by Let's Encrypt. So now with a few clicks, our domains and APIs are encrypted and secure. Now that we have finished setting up and deploying our services, we can go over the basics of how the system works and what Phoesion Glow does in the background. Phoesion Glow offers the following basic components for structuring your cloud setup. Firefly is an entity that hosts your business logic. This is a component that runs our code. Prism is a mediator and API gateway. This is a web server that will pick up the incoming request from the outside world. Kaleidoscope is a service bus that is responsible for connecting all entities together and routing requests to and from the proper endpoints. Lighthouse is a command and control center that manages all entities. Blaze is a GUI tool developers and admins use to connect to the Lighthouse and perform actions like deploying and managing the services. There are also CLI tools for automating tasks, for example, deploying your services that can be used to build your CI/CD pipeline. This is how the components work together to handle the incoming request from an external client, for example, a browser. The request is received from the Prism that is then forwarded using Kaleidoscope, a service bus to the appropriate Firefly that is running our code. The response is then returned to the Prism for responding to the external client. In this slide, we can see the deployment and rollout flow of our services. The developers pushes the deployment request and files to the Lighthouse and informs all the entities to begin rollout. Each entity then pulls the new deployment from the Lighthouse and applies them locally. We can monitor either each service from our command space or examine all the entities that participate in this command space. Here we can see the Prism and its health and statistics, the Kaleidoscope that will be our service bus, and the Firefly that runs our actual code. You can also see logs, console logs that are produced by each service. To summarize, in this video we looked how we can set up a server and deploy our services. We've seen how we can manage our services and the basic architecture of the system. In the next video we will talk about service-to-service communication. Thank you for watching.